I have an introduction slide, which you've just preempted, but it's in the deck, so I have to go through it. As you said, I'm HollyCummins. I'm the delivery. You did it better than me. How embarrassing is that? I'm the technical lead for the Bloomix garage in London. I work for IBM. I've been with IBM for 15 years. I've been with IBM basically my whole career before you start trying to work out how old I am. I've worked for most of my time in IBM, I've worked on WebSphere. One of the great things about IBM is that you can do such a huge range of roles. So I've worked at the bottom of the stack doing garbage collection performance. Now I'm working much more at the top of the stack doing services, but I spent a lot of time firmly in the middle of the stack with WebSphere. I've written a book because I've done a lot of OSGI work in my time at IBM, and as Alex will tell you, OSGI is awesome. And should you wish to know about enterprise OSGI, or even what it is, there is a book that can tell you. What I do now is I am the technical lead for the Bloomix garage in London, still with IBM. So then the question naturally is, what is a Bloomix garage? It's not where we store our cars. It's really IBM's innovation center. So we try and operate like a startup, even though we're a big company. And that helps us do two things. It helps us talk to other startups on the same level without seeming quite so big. And it also helps us talk to large enterprises and understand a bit of the nimbleness and the agility and the lack of overhead and process that can sometimes cause problems in larger companies. So really, with all of that, the aim's absolutely about innovation. It's about saying, what can we do that hasn't been done before, that's disruptive, that's going to solve user problems, that we're going to do in a really efficient way without having to spend a lot of time dealing with things that aren't actually adding value. So should you wish to know more, this is a tracked URL, so please do go to it. You can learn more about Bloomix. You can sign up for a trial. As a reference, how many of you are using Bloomix? How many of you have heard of Bloomix? Right, so those of you who have heard of it should go and use it, and those of you who haven't heard of it now have heard of it, so that problem's solved. So Bloomix is really sort of an evolution of where we are in computing, and at the other end, still talking about IBM. I think we get so excited by what computers can do now that we take it for granted, and we forget to think about the history of what we've done. And of course, Alex has given us a really good illustration of how so much of the things that we do now are really connected to the past with things like the telegraph protocols and that kind of thing. They still affect us, but some things have changed a lot. So in the 40s, Popular Mechanics said computers in the future may weigh no more than 1.5 tons. You know, the peak of engineering is to get it down to 1.5 tons. And Thomas Watson from IBM said, I think there's a world market for maybe 5 computers. And if you think about that, I think most of us have 5 computers just in our bags most of the time, because you've got your watch, you've got your phone, you've got your Kindle, you've got your laptop, you've got your other phone, and then all of a sudden you're carrying 5 computers before you even left the house. And it's easy to laugh at this prediction, but actually it turned out that it was true for 10 years. And if any of us, I think, would make a tech prediction that would last for 10 years, we'd be pretty impressed, and we'd be like, yeah, Gartner, hire me, I know everything. So it's not quite as stupid a prediction as it now looks with the benefit of 60 years of hindsight. And the reason that Thomas Watson thought there was a market for only 5 computers was because back then computers were these great big 1.5 ton things that cost an awful lot. So there wasn't going to be a lot of companies or people that could afford them. Whereas now computers are so ubiquitous that they're in our phones, obviously, they're in our cars, and they're really, really in our cars as well. So now when you buy a car, you have the option about whether it wants to tweet for you and that kind of thing, which always seems like a bad idea to me, but maybe I'm old-fashioned and showing my age. And you get toasters that can print the weather forecast on your toast. And I had a fridge. I knew I was in trouble because I had a fridge, and the fridge had a computer. And I thought the fridge should keep things cold, and computer said no. And so instead, anytime you plugged this fridge out, when you plugged it back in, it would beep for 6 hours and just refuse to do anything other than beep. And so they what they had to do was they had to go and they had to change the motherboard in the fridge to try and persuade it that it wanted to cool things. And I thought, just bring back the system that just had the coolant and that just made things cold without giving me a lecture on whether it wanted to make things cold. And if I thought the fridge was bad, of course it could be getting worse, because what we're moving towards now is this notion that not only does everything have a computer in it that may or may not do what you want, everything is talking to everything else. So your fridge is talking to your oven to say, yeah, low on groceries, I wouldn't let her cook a meal tonight. And your phone is talking to your fridge to say, yeah, gaining a bit of weight, didn't do her exercise today, perhaps no dinner tonight. And sometimes these can be really good, but of course sometimes when it's things like your food deciding whether you're allowed to eat, or hackers deciding whether you're allowed to eat, it's a bit more concerning. But leaving those slightly alarming possibilities aside, for us in this room, why is the Internet of Things interesting? Well, there's a really good business case for why the Internet of Things is important. It's a huge growth area. It's absolutely going to change the way all of us interact with technology. And for those of us working in the technology field, we want to be ahead of that curve, and we want to be taking advantage of this opportunity and allowing our customers to take advantage of this opportunity. Great. On the other hand, why are most of us in this room interested in the Internet of Things? Because it's so cool and so fun, and it flashes lights, and actually it's just a really good toy. So, for those of you here, how many of you are interested in Internet of Things at a business level? No hands. How many of you are interested in Internet of Things because it's actually quite cool and fun? Number of hands. And how many of you actually think Internet of Things is really boring and you wanted to know about Unicode? Oh, come on, some of you have to lift your hands, otherwise it's just insulting. Right, okay. So why am I interested in the Internet of Things? Well, I've always thought it was a bit cool and a bit fun, but I really got interested a few years ago, because IBM, I've been developing webs for ages with IBM. It's probably a lot of you use it. It's, I think, now a bit of a classic traditional product. It's got a really strong legacy. It's got a really strong history. It is not the smallest or lightest product, and it's not the most youthful product because of that history. And we looked and we said, well, we need to modernize this. We need to make it a good environment for the cloud. We need to make it a good development environment for laptops, where something that's suitable for a mainframe, something that's suitable for a server, maybe it isn't really the most suitable thing. So what we did was we ripped out the kernel and we kept all of the libraries. And the idea behind doing that was that the applications would run in exactly the same way, because it was using the same EJB library, it was using the same JPA library. But this OSGI-powered kernel could be super nimble, super lightweight. We could make something that was really modular, really dynamic. And we did that, and it worked really well. And it worked so well, in fact, that it could run on a Raspberry Pi. And now everybody's running everything on Raspberry Pis. But at the time my colleague Simon Maple did this, it was the first one that was done. And it was even more impressive at the time as well, because now Raspberry Pis are pretty hefty machines. But at the time, it was the Raspberry Pi A. It had 256 meg of memory. It had a wet sock for a CPU. So it was really kind of quite surprising and cool that the Raspberry Pi could run WebSphere. And we went a bit crazy as well. So we ran it on the Raspberry Pi. We ran it on Android phones as well. So we rooted the Android phone, and then it could run WebSphere. And of course, none of us wanted to use our shiny new Android phones to root to then run WebSphere on. So we were using our old Android phones, which made it even more impressive that it worked, and it performed really well. And so I had a couple of demos with the Raspberry Pi and WebSphere, and they were pretty cool, but they just sort of sat at the front of the room, and you couldn't do anything with them. And I thought, well, and they had robustness problems as well. So I thought, well, what can I do to make this demo more dynamic, something that people can really interact with, and also something that avoids some of the demo problems that I had been having. So I thought, I know, the first thing I need to do is I'm going to switch from a Raspberry Pi that was a little bit slow to a PCduino, which is sort of a cross between a Raspberry Pi and an Arduino. So it's still in that single board computer family, but it's got a little bit more power and a higher price to reflect that. It's got built-in Wi-Fi, which is really good, because on the Raspberry Pi, I always found I could communicate with an Arduino or I could communicate with the Wi-Fi, but I couldn't do both at the same time. So I had to, if I tried to read the Arduino more than once every 10 seconds, basically I just lost my network connection. And that's not really good enough. So the other problem with the Raspberry Pi I found was that it was really slow, and one of the reasons it was really slow was because it had this SD card, whereas the PC Arduino comes with onboard flash storage, and it's a lot faster. It's got a lot of RAM, and again, this is comparing to quite an old Raspberry Pi, so really impressive RAM. It's got onboard Arduino pins, so you don't have to have a separate USB connection to Arduino, and the best of all, it's got a battery connector. So I thought, oh great, this is going to be really good for demos. So what I did was I took my PC Arduino, I installed WebSphere Liberty on it, and then I attached some sensors to it. And then I can run an application server on there, I can connect to it, and I can see what's going on. And this is particularly important because sensors are always good because sensors are cool. But if you take an application server and you put it in an environment which is padded, the heat dissipation suffers a lot. And what do computers do? Computers generate heat. So I had created this thing that was in real danger of melting down anytime I used it. So I had to have the temperature sensors there so that I knew at what point I should panic and stop the demo. And so what I did is I did some textile engineering. So I figured out what I wanted to look like. I made my patterns. I did some cutting and some sewing. And what I came up with at the end was this, which is the WebSphere sphere. And I was really, really pleased with that pun, by the way. And this is the cuddly application server. And it's the world's first cuddly application server. And to my knowledge, it is still the world's only cuddly application server. And if you Google for cuddly application server, I don't know why you'd do that, but I have done that, I have to confess. And there's 2 whole pages that are about me. So I own the market for cuddly application servers. And this also has the distinction of being the world's first throwable application server. So, throwable technology, I thought it was a pretty silly thing when I did it. But anyone know what this is?
Is that the long thing that you throw away?
Yeah, exactly that. It's a throwable microphone. And there's a whole industry segment now for throwable microphones. So there's this, there's a whole bunch of others. So throwable technology is the way of the future. It's not just a stupid thing we do as a hobby. But going back to the WebSphere sphere, so what I was aiming for, hopefully this picture shows you. So I'm seeing 1 or 2 smiles, and the rest of you are looking really confused. And that's because it sort of looks like the WebSphere logo, but not entirely, because it is rather lumpy. So what I was going for, and this is the device in question, is a computer case to pad my system. And you should see, so every time I thump it, well, it did it a couple of times. Yeah, there we go. I don't know if you can see it. It's got the bounce sensor, so it bounces. It flashes when it bounces. And so the way that's done is I've got LED sequins that are acting as an interface. One of them is supposed to be a power indicator too. We'll come back to that one. It doesn't seem to be working at the moment. But the thing that makes the LED sequence work is stainless steel thread, which I always keep this slide up because I just think it's the coolest thing ever. It's conductive. It's really quite cheap, so you can just buy it just to play with it and go, ooh, it's conductive and it's thread. It's really cool. You can solder it, you can sew it. It's just really awesome. So let's have a look at the actual application. So if I hold this up, nope, I've just spoiled the surprise there. That's supposed to be a link, and it's a bit erratic. So hopefully you saw it was flashing as I visited, and I can fill in the poll.
Holly,
Yeah.
because you're not on minutes.
Oh, thank you, thank you. Oh, now I've done it. Hooray.
So I come and hold it for you.
Excellent, excellent. So you can see I've got the result of my poll, and I've got my little sensor, and it's saying, yeah, it's only 23 degrees, not too bad. That's because it's outside the sphere. And you can see it's getting cooler as well, which is kind of encouraging. So, and I'll hit it one or two more times so we can see the exciting flashing lights, because the lights are very exciting. Right. Oh, that's brave. I'm not sure if I'm that brave. So, great. I can see you're all astounded at this technology, and as the slide says, I worked really hard on it, and I showed it to my mum, and she looked at it and she was like, I'm very proud of you, dear. But what's this for? Why would anyone want it? Well, really, who wouldn't want an application server in a cuddly ball? But let's go on to the technology. Now, you may have noticed that I'm not throwing it around the room, and that's because it's attached by a lead, which is because the captive portal Wi-Fi defeated me. So I will hand it round now that you've all seen it working. In fact, I'll hand it round without trying to squidge it into the ball, and that way you can. So please don't throw it when it's outside the sphere. There's always a challenge, because I think as software engineers, we really want to do test-driven development, and we want to test everything as often as possible. But with this particular system, the more you test it, the more likely it is to break. So I didn't really test it until the first time I gave the talk. And then I didn't really know if it would survive throwing or not. And so I threw it out into the audience, and they threw it back, and it was all working great. And then it went slam into the back of the wall, because it wasn't a very good throw. But the good news is it did survive that. But I have had some technological challenges along the way. So the first one was I got my shiny new PCduino. It has an HDMI connector. I tried 6 monitors. None of them would ever display anything. I have no idea why. I can use it headless, that's fine. There are some things that are much harder to do headless, like connecting to a captive portal network. But I had some other problems as well. So you saw that the power light isn't working. And I think what's probably happened is that one of the wires has snapped. So it's sort of like a loose connection, but much more fatal. And it's particularly fatal because a lot of that is accessible. You can see it's outside now. But the things like the wiring for the sensors is inside it, and it's inside the padding. And in order to get to that, I have to take it apart. I have to take every single bit of padding out, and then find the loose connection, and then put all the padding back in. And it's really, really annoying. I had some other problems as well. So one of the things that I thought was really cool about the PCduino was that it's got an onboard battery connector, and I thought this is going to solve a whole bunch of power problems that I'd had with the Raspberry Pi. And it's got JST power, so I thought, great. But it turns out that the PCduino is JST SH, and the standard battery that you buy if you want to buy a battery for your IoT project is JST PH. And of course, those two aren't the same, which is really, really obvious once you know. And when you don't know, you just sit there with the two connectors going, it's a JST connector, why doesn't it work? And then you talk to someone and you feel really stupid. So lesson learned. After this page appeared after I'd done my learning process, which is that there's a nice web page saying, oh yes, if you buy it, you're going to have some difficulties with the connector. I thought, why did they design it like that? So it's okay though. What I did is I managed to do some soldering, and I switched the connector. So I got a standard battery, and I played around. But then I discovered that there is actually a reason why the connectors aren't the same, which is that if you take a battery, it's 3.3 volts. To run all the sensors, you need 5 volts. And that's why they don't just plugged together out of the box. So this is what it looked like, and it was enough to power the computer barely, but not enough to power the sensors. So no problem. I can just take, this is just a standard battery for charging phones. I can connect that up. Great. I did have some problems, which is that because with the PCduino, it's got those pins, and those pins are all quite visible. And if you lay something across the pins, what happens is it shorts the pin, and then that's, well, the computer will survive, but certainly it will reboot itself, which isn't what you want. So I had to put in some protection. So uncovered metal batteries in the same enclosed space, bouncing around, not good. But I had a sock, and it turned out it was the perfect size. So the child will never miss it. It was fine. So all good demos involve a sock. And I was promised when I came here to speak that I could speak at the Docklands LJC, or I could speak at the Socklands LJC. So I fixed your logo for you. So the USB battery, it was working pretty well for a while with the sock. But then I had a further problem, which is that there's quite a lot of cramming that you have to do to get that into the sphere. You can see I thought I'd got the pocket the right size, but because of the padding, that tends to make the pocket a lot smaller than the physical dimensions. So 30 seconds before a demo, I was going shove, 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 shove in a slight panic, as one does. And there was a USB connector, and the USB connector is not really connected in a way that is designed to be physically strong. It's just designed to be electronically strong. So I ripped it off the board, and that was the end of the power. But it's okay, because it turns out there are two USB power connectors on a PCduino. So I just plugged into the other power connector, and it all worked. So that was great, until I ripped that one off as well, about a month later. So what does that actually do? I did have the 3.3 volt battery on there, so it did have enough power to sort of limp along, but I knew I could never charge this thing again. And the other problem I had is I had a bounce sensor on it. And the way the bounce sensor works is it's analog. And you'd think, that it's digital. And we tend to think that digital is a lot better than analog, but it turns out digital is also a lot more sensitive than analog. So if you have a sensor that's going to read 0 or 1, and you change the voltage going into it, that often tips it from the point where it will read 1 to the point where it will read 0. And then that means that everything stops working. So the way the bounce sensor works is that it will always read 1 unless there's a shock happening, and then it will read 0. And if there's insufficient voltage, it will always read 0, which is why it had that. So carrying on. Surely nothing else could go wrong, right? Well, I had a sensor, and I was testing it before I did a demo, and there was this smoke. And the PCduino didn't turn on, and nothing worked. And it turned out that one of the sensors had shorted, and of course, because it's all connected to the whole computer, that meant that nothing worked. So I had to buy a new one. And it took a while to arrive. And then the whole PCduino board just gave up the ghost, and no matter what I did, it just wouldn't work, which wasn't too surprising, really. I don't think it can be taken as a reflection of the quality, because I had been throwing it around the room. So my mum, I think because I don't email her enough, she tends to stalk me online. And so she emailed me and she said, oh, I saw a video of your sphere talk. I thought you handled the fact that it didn't work really well, but where are the videos where it does actually work? And I had to go back and say, well, there aren't actually any videos where it really works. So then after that, I think because I'd sent the email, it worked. It was amazing. Twice in a row, it worked. No one in the audience was more surprised than me. I was like, wow, it's a miracle. And then what happened? Well, it turns out that because it tends to look a bit like a bomb, and because it's quite big, I usually check it when I travel, which is fine until I had a connection, and then my luggage got lost. So I had to give a demo without the demo at all, which was a bit embarrassing. So surely nothing could go wrong after that, right? Well, it carried on. And one of the pins snapped on one of the important components. This component is called a power boost. And what it does is, this is the way I solved my voltage problem. This takes the 3.3 volts, and turns it into 5 volts, which is great as long as all of the pins are there. When the pins fall off, snap off, bit of a problem. So I had a secondary problem, which is that I might have been able to fix it, but I didn't have the proper equipment. So there is a lesson learned, which is that if you're going to do IoT, don't try and do it with the wrong soldering iron, because it just doesn't work. Buy the proper one. This didn't make me very popular at home when I also tried to use the wrong thing to support it on the kitchen counter and just ended up burning everything. So, but it's okay, because I replaced the part, and then it still didn't work, which was a bit depressing. So I replaced the part again with what you're seeing there, which is the super shiny thing that has to work really well. And it still didn't work. So I thought, what's going on? And I looked at my battery, and what this picture doesn't show is that it wasn't working with this setup. And all of that tape is concealing a great big hole in the battery. And I looked at that and I thought, well, it's just a little bit of a hole in the battery. That doesn't mean anything bad, does it? Well, apparently, if you damage one of these batteries, the main thing that happens is that it explodes. And so I sort of looked at this, and I thought, maybe I'll carefully take it out of the house and put it in a bin, which isn't even what you're supposed to do. What you're supposed to do is really elaborate things involving sort of salt water and circling around it 3 times and sacrificing something. But I thought, well, the bin's far enough away from my house that hopefully it's okay. So I bought a new battery. And you can see that this was my recent adventure. This was my Sunday adventure, was trying to make sure everything worked and discovering I had a problem. So I bought a battery, and then I realized that what I thought was fast delivery wasn't fast delivery. So I bought a second battery. That one actually did arrive in time. So meanwhile, on Sunday, my partner and I was like, sorry, I can't do anything because I need to try and make this work. And he says, you've got to stop doing this talk. It's not reliable enough. So I have to say as well, I have to confess, I didn't tell him about the fact that we had a battery that was in grave danger of exploding. So if you're going to do Internet of Things, well, think carefully about it. It is a lot of fun, but if you're going to do it, you're going to need spare money. I'm in the financial district, so I think you're probably okay for that one. You're going to need a lot of time. That one's maybe borderline. And the other thing you're going to need is a really high tolerance for stress. And again, probably financial sector, you're probably okay for that one. So when I think about the poor demo and the fact that it's had so many problems, sometimes I think, oh, that's a bit sad. But then we have this, I'm in WeWork in Moorgate, and they've got this plastered everywhere along the walls. So I keep thinking, no, I've just found 10,000 ways that an IoT demo can fail. So, all very embarrassing for me, all very entertaining, but what does it actually mean technologically? Is there any significance for this apart from the fact that IoT gives me headaches? A friend sent me this, and I felt very sad while reading it because it's probably a little bit too small to read. But it says, we're going to use the NATS protocol with a Raspberry Pi at 1.2 gigahertz. Oh, pretty impressive. And with this new Wi-Fi chip, we can do 10,000 times more power. Amazing. The audience are really impressed. And look, watch carefully. I'm making the transfer. Total game changer for IoT. And there you go, the LED is blinking. And I think with a lot of these IoT demos, certainly at this scale, they do actually end up being something that has the physical manifestation of a blinking light. And it takes a lot of work to get there. My partner, again, he looked and he was like, a lot of your demos are doing something really easy in quite a complicated way. And I was like, yeah, basically. But leaving the blinking lights aside, I think there is actually sort of, some interesting technology and some technological significance to this. So the first, single board computers, I think it's easy to take them for granted now, but I was at Geek Out recently, and they were giving them away just with your conference bag, you got a pass and you got a Raspberry Pi Zero because they were so cheap now that they're basically disposable. It's just incredible the computing power that we can kind of go, and chuck. The other thing, application servers. I think they're still a little bit out of fashion. That there was a long time when they were really, really big. They were something that you try to avoid, but actually application servers, containers, lighter than you think and can save a lot of time, so really useful. And particularly Java EE, there's a lot of really handy programming models in there. A lot of us haven't recovered from the first version of it when it was pretty terrible. But since then, there's stuff that I think, we sort of forget, and we use Java EE without even realizing we're using it because we're just thinking, I'll just use this handy annotation, I'll do this way. And actually, it's Java EE, it is lightweight, it can run on a computer as small as that, and it can save time. So with this application, I always said I would never share the source code for it. And I now have shared the source code for it. But the reason I said I would never share the source code is what I did is I said, well, I need a servlet, so let me cut and paste this from here. And then I want some CDI, so let me cut and paste this from here. And, I think I want to do persistence, so let me drag in some JPA from here. So I did all that. Need to expose it by REST, probably, so let me bring in some JAX-RS. Probably WebSocket, that will make the temperature response a lot better. So let me bring in some WebSocket. And then what this is showing is that this is a bit of the Liberty log. And you can see I have in there, I've got JAX-RS, I've got JSON, I've got JPA, I've got CDI, I've got servlet, I've got JSPs, I've got JNDI, I've got EJBs in there. I didn't put in the code snippet for EJBs, but I've the regular push of the temperature data is done with an EJB because it's actually quite a convenient way of doing a scheduled bean. I've got WebSockets in there. Is this how I would recommend writing an application for resource-constrained hardware? Probably not, no. And this is why I didn't share the code, because it was a little bit embarrassing. But it is kind of interesting that I was able to write it in such a slapdash way and without optimizing really heavily. Well, in fact, without optimizing at all. And arguably, I was de-optimizing as I went. And it still basically worked, and it was still pretty responsive. And another thing, one of the things that enables that, again, is the shift in how application servers are, because Liberty, powered by OSGI, which is amazing, only installs the features you need. But the optimization to only install the features you need only really helps if you're using a small number of features. For my application, I was actually using a lot of features because I have a lot of programming models in there. And there's kind of an interesting thing. This is quite new, and I think it's evidence of the shift in the way that we're using Java EE. This is microprofile, and I think there's some discussion about what it actually is going to be, but it's a subset of Java EE that a lot of the main application server vendors are going to support. So IBM is in there, others, Pyara, Red Hat, and it's going to have just probably the ones that you would want for a microservices architecture. So it's going to have the JAX-RS, it's going to have those. And it's really small and it's really light. And it means that you can use this, you can get a fairly standard set across different vendors, and it's not going to be huge. So all of this is really nice, but is it actually Internet of Things? If you remember, the architecture is that I have the application server running in the sphere being thrown around the room. It's not really connected to anything else except for my laptop that's viewing it. And in this particular case, because I had the Wi-Fi problems, it was literally not connected to anything else except my laptop that was viewing it. Whereas, so here we have, if it was a Raspberry Pi, Internet of Things, it's got a thing. It's an embedded thing for sure. It couldn't really be more embedded because it's in a sphere. It's got network, but it's not really doing anything meaningful on the internet. And really for Internet of Things, what we really mean is we mean machine-to-machine communication. So I have a revised architecture, which is a more classic IoT architecture, which is that on the sphere, it's running at the same time. I have a little Java agent. It's an MQTT client. It's pushing messages up to the cloud, and then the application is running on the cloud, and I can access it, and I can see the status. In this case, Bluemix, it has an integration with IBM's Internet of Things platform. Used to be called Internet of Things Foundation. Really good MQTT broker, really nicely integrated with Bluemix, running the application on Liberty in Bluemix, so all good. So we can have a look at that. Unfortunately, I'm fairly sure that this one isn't working, or rather it doesn't have the sensor data.
Well, then you need to request it.
Yeah, I'm remembering. Ish. Right. So that's the local one. So you can see temperature data. If I go to then I can fill in the poll. So far, so good. But annoyingly, there's this clear data button, and I cleared the data because that seemed like a good thing to do, because the data wasn't very accurate, because it was just the readings for when I didn't actually have the sensor, so it was showing that the temperature was 360 degrees all the time. So I cleared the data, and then I realized that in this building I couldn't get the data. So I have no data. But I can fix that. So I can do you can watch Eclipse later, right? So I can do scrolling problem, window problem. So at some point, that should change, hopefully soon. But not that soon. Give it a minute or so. So this is, I've got a DevOps pipeline set up in Bluemix, running Cloud Foundry. And it will be doing a push momentarily. So. Cool. It built, which is reassuring. And now it's in the process of doing a deploy. But it will take about a minute or two, which in demo time is a lifetime. So I'll go back to my slides. So as I mentioned, Bluemix does have really good support for IoT. It's a really natural platform for IoT, both at a hobbyist level, but also at a professional level. So this, that one in the top right is the Internet of Things platform, which is a fancy way of saying MQTT broker. And in Bluemix, it's a very cloudy environment, as you'd expect. And so the way it does the integration is that everything goes in as a VCAP service. Some of them get auto-wired, auto-configured. Some of them you have to get the credentials out of the VCAP services, which is a JSON object yourself. So in this case, JSON object for the credentials for the Internet of Things Foundation, drag out the credentials, and then connect. So, any questions?
Does Bluemix support any language other than Java?
It does, yeah. So the short answer is it supports every language because you could do custom build packs. So the runtime which supports the application is called a build pack, and you can do custom ones. But realistically, that's probably not going to be the first thing that you're going to do. And almost every language that you can think of has a build pack for it. So I thought a while ago, I'd do a really cool demo and I'd find a really crazy language and I'd do a Bluemix build pack for it. And then I realized that almost every language I could think of, except for I think Ada, had a build pack. So I was like, oh, okay. But it's also out of the box. It's got Java, it's got Node, I think it's got Python and Ruby out of the box as well. It's got, on the top bit, it's got a runtime section, and they're there. Any other questions?
After your experience, are you planning any new projects?
I keep saying I'm not going to do it, I'm not going to do it, and then I do. So I don't know if you noticed when I went by in the build and deploy, when I navigated to my project, there's a whole bunch of other ones that were called Catastrophe, and that's my next demo. And it's cat themed because all good demos involve cats, and it's Catastrophe because I have experience of live demos. So that one's a microservices one where I thought, what I really need to do is I need to take the micro in microservices by running it all on Raspberry Pis. Because with microservices, I think what we often forget when we look at the theory and we think, I'm just going to run this on one laptop and it all works really well. And then you take it to a distributed system and it falls apart. And I thought, I can do that falling apart bit for you. Unfortunately, that demo does fail too regularly as well. So I thought, I'm going to make a demo that's going to fail. It's going to be really great. And then I gave the demo and everybody was like, it failed. So that was a long way of saying, yes, I haven't learned yet, unfortunately. Any other questions?
Anyone else is
Yeah.
So in the beginning, you mentioned something about Raspberry Pi and Wi-Fi and pins. But does that, can you repeat that? That kind of makes similar issues.
Yeah, so with the Raspberry Pi, the way I did the Wi-Fi is I had a USB dongle, and then I had the other USB port I had connected to my Arduino. And so what would happen is the USB bus, I think, had really limited bandwidth. So at sort of a simplistic level, the way I understood it was that it could decide whether to take USB traffic from one port or for the other, but it couldn't take them from both with any kind of simultaneous behavior. So if you wanted to talk to one port, you basically had to sacrifice the other port. And the switchover time was really long as well. So it wasn't like, because you sort of think, that's fine, it has to share between ports, but how much can it be doing on each port? But it really was, I had to, if I used the Arduino port more than every 10 seconds, I would lose Wi-Fi. So I'd get a reading, but then I couldn't put it up. But I had all sorts of problems with the Wi-Fi on the Raspberry Pi. So the first problem was just getting the driver to work, and that took me forever. And then, I just found that it was really unreliable in connecting. I think, again, because there wasn't enough power on the board, like physical electric power. I had that too. So I think that, again, that was an old Raspberry Pi, and it might be getting better. And I think they're now saying, I don't know if they've released this one, but they're talking, for the longest time they said we're never going to do one with Wi-Fi because it would bring the price up too much. And I think now they're saying, okay, we're going to do one with Wi-Fi because that's the user experience that you want, really, is you don't want it to be tied to a wall. You want to be able to do interesting things with it.
So cheap answer is buy 3.
Is that the one with Wi-Fi on it?
Works fine for me.
Yeah, okay. Thank you.
Yeah, I think it was £35, so it's got up there.
Yeah, because I think when I first looked at the 3, it didn't have Wi-Fi, but then the next 3 did have, yeah, thank you.
Maybe I don't know.
Yeah, I think that's, yeah,
So,
that, yeah.
yeah, it's not much fun. You don't need to get it working. It just works.
Any other? Yeah.
Have you ever thrown your cuddly application across the room in anger?
No, so it has thrown really long distances and survived. But I think I've just managed to keep just that sort of hold on my temper of, you know, I hate you, but I'm not going to damage you further. Any other?
Yes. So, Holly, no one's forced.
Thank you. It would be sad to deprive everybody of a catch session. So now that I don't need it for anything, I can try and squish it in, and we can have a brief round of catch. I should have done that with the questions. Actually, I should have used it as the throwable microphone.
Okay, so a couple of announcements. So one important one, not so important. So not so important one is the next session is going to be held at Barclays next month. Far more important is we're going to Davies after this, which is our official pub downstairs over there somewhere. It's Alex's last day at Credit Suisse tomorrow, so come along and buy him a beer or two. Thanks a lot, guys.
Hooray. Oh. Bad start. Luckily, it's well padded, see?
This is where you find no one can catch in the audience.
Yeah.